Okay, everybody, welcome back. And in today's lesson, we are going to look at Chapter 12 of AFDA, which actually takes a little bit of a departure from what we've done previously. In Chapter 12, we're going to look at just general functions. So far in this course, we've talked about specific functions, linear, quadratic, exponential, logarithmic. But we haven't talked about really just their general qualities that apply to every function. And that's what we're going to do in this section. We're going to, in A, recognize the graphs of parent functions. So we'll have to talk about what a parent function actually is first. And then we're going to do some transformations on these functions. So transformations from geometry, remember we're going to move it left, right, up, down, flip it upside down, flip it left, right, that sort of deal. But before we start anything, we're talking about right here these two objectives first, and they both deal with this idea of a parent function. And that's what we're really after in this lesson. Obviously, we're going to move those functions around. That's transformation. But we're really after in this lesson memorizing parent functions. So when we look at our paper here, literally we have a big table and we're going to have a bunch of functions that we're going to have to memorize. So for each function, there's going to be three things we need to understand. The actual name of it, the graph, and then the equation here. And if I give you one of those representations, you're going to have to be able to tell me the other two. So this first part is literally just going through and memorizing this. So our first function is the most basic. It's called a linear function. And we're only talking about parent functions here. So a linear parent function is the simplest possible graph of a linear function. Well, a linear function is a line, and the simplest line I can have would start at the origin here and have a slope of 1. So you can see I'm graphing a slope of 1, and I'm actually going to come the other way too. And then we'll connect those dots. And the equation of that function, f of x, is simply x. Y equals x. F of x equals x. And that's what we're doing in all of these. So linear kind of stands alone because linear was really an Algebra 1 topic. You learned about y equals mx plus b. We talked about that today in our warm-up, actually. But moving on, we're into some more complicated functions. So the first more complicated function, I'm actually going to put it down here because I want to kind of save a couple things. Well, I'll do this way. The first more complicated function would be really what is two linear functions kind of put together. And actually, it's called something else called absolute value. And the equation of an absolute value function is f of x equals the absolute value of x. Well, think about what that does to my graph. It's basically the same linear function. So I'm actually going to keep this part of my graph. So starts at the origin and a slope of 1. But now think about, what does an absolute value function actually do? Well, it takes every single x value and makes it positive. So this part of my graph is not going to be negative. I can't plug in -5 or negative whatever, 1, 2, 3, 4, right here, 5, and get -5. I can't do that. I can't get that point. Because if I plug in -5, 1, 2, 3, 4, 5, right there, I'm going to get +5. And that's what happens on an absolute value. That all of these negative values here on that left side are actually going to flip and become positive. And what you end up with is a big V, and I didn't really connect those dots real well. So what you end up here with is a big old V. And you can see linear and absolute values are kind of related in that way. They're not really opposites of each other, but they do have a relationship. Okay, so our idea, again, we're going to have to memorize absolute value. There's my graph. There's the equation. Linear. There's my graph. There's the equation. Now we're going to get into some more complicated ones. So at the bottom here, the first more complicated one, we're going to do one that you already know, is a quadratic. But a quadratic function, if you remember, was x squared. And what did a quadratic function look like? Well, it started here at 0. And then my point, if I plugged in 1 for x, I would get 1 for y. So my next point is 1, 1. Now think about it. If I plug in 2 for x, what do I get? I get 4. So 2, 4 is right there. If I plug in -2, I would still get +4. If I plug in 3, I would get 9. 3 squared is 9. So right there. And there's my quadratic parent function. Like so. These points all come from me plugging in these values down here, though. That's how I'm getting these points. And those points are actually the more critical part of this. You want to be able to memorize where are these points, because you're going to transform these in a second. Now what we're going to do is I'm going to take that quadratic and I'm going to find the inverse of it. And that's called a radical. And a radical function is the square root of x. So now think about again, when I plug in these points here, what's a square root going to do? If I plug in 0, I'm going to get 0. If I plug in, well, 0, 0. 1, square root of 1 is 1. Now, to get 2, I have to come all the way out here to 4, because the square root of 4 is 2. To get 3, I have to come all the way out here to 9 to get that. Now, can I get negative values on a square root? Well, what's the square root of -4? Well, it turns out that doesn't exist. It's called an imaginary unit, but we're not going to worry about that in this course. That's an Algebra 2 topic. So I'm not going to have any negative values for square root. So there's my graph. Right, and we're going to continue that trend. Whoops. We're going to continue that trend here for a couple more. We're going to do a cubic and a cube root. And these actually follow the same pattern. This is x cubed, and this is, whoops, cube root of x. So again, I'm going to get these simply by plugging in points. I'm going to plug in 0, 1, 2, 3, and see what I get. For cubic, whoops, wrong point. And definitely didn't want to do all that. There we go. Right there. There's my function for cubic. Now, cube root will be the opposite, but the difference with cube root is that you can have negative values for a cube root. So unlike square root, I can have negative values. The cube root of -8 is -2. Or I'm sorry, yikes. Yeah, oops. I did those as radicals. My bad. Let's go back. That's why we definitely want to go slower through this. So when I did this, these points were fine, but 2 cubed right here, 1, 2, 3, 4, 5, is right there. And negative 2 cubed is negative 8. These are my graphs right here. There we go. And then over here, they're going to be the same thing. Like so. There we go. Okay. Sorry about that. Yeah, I was doing square roots, but I really wanted cube root. So there we go. I can't have negatives on the cube root, and these are my points. Again, these points are simply coming from me making an XY table and plugging in. Again, you can use your calculator too to find these points. Just graph it and look at your table. And then the last two we're going to do, we've actually already touched on a little bit. Exponential and logarithmic. Well, it turns out exponential and logarithmic, same idea. We're going to use, we talked about what bases were, and I always find that 10 to the x is always a good one for a parent function because it'll do this for, whoops, not there though. So right here. And again, you want to verify these on your calculator. But there will be my points for an exponential function. And again, what am I doing? I'm plugging in 0 and getting 1. I'm plugging in 1 and getting 10. These are my values that I'm plugging in. For logarithmic, it's log x. And this actually looks pretty similar. But you can see it's kind of flipped around for a log. So each of these pairs have a relationship. They're all inverses of each other. We'll talk more about inverses in a later course, but for right now, you just want to see that these are inverses. They're kind of flipped on each other. Our last section, I'm actually going to have to clone a page here. There is one more graph that I've got to put on here for you. And it's one that doesn't get really an inverse, so it kind of goes by itself here. And what it is called a rational. And a rational function, x is on the bottom of a fraction here. And this actually looks a little more different because x cannot equal 0. So what you end up with is these two little lines called asymptotes. And your function kind of does this. It kind of moves around those asymptotes. It moves around those lines that it can't equal. So what we have here are 9 parent functions. Your first job in this course is to simply recognize those and be able to identify them. And that's what we're going to do on these next few pages. So on this page, literally, if I say name it, I want the name. So as I go through here, these are a little harder to see, but this is going to be a log. You could probably put radical too, just because the shape's a little difficult to see. But because I'm giving you a parent function, the parent function of a log goes through that 0.01. Okay, this is absolute value. Here's exponential. At the bottom here, Here's my radical, and I put this here so you could see the difference between radical and logarithmic. And 5 is cubic. So you'll have to go through and just simply identify the name of it. On the next section, I say identify the name again, but I'm actually want you to name the function or write. Let's just put write the function. So what I'm looking for in these, not the name of it, but the actual equation. And the wording of that can be a little tricky on the directions. So if you have any questions on a quiz, feel free to ask, what am I asking for? But again, I'll be looking for log x cubed, exponential 10 to the x. Here, this is a radical, so square root of x. Absolute value, there we go. And the majority of what we're doing tonight is simply memorizing that. So make some flashcards if you have to, but we'll go through because you will need to memorize that for a test. Then what I'm going to want to do is actually start looking at transformations of this. So I'm going to give you a description, and you're going to have to draw or identify a transformation. You can see here which one of these is a cubic function, so I need to know the name of the word cubic. And I need to see which one went 1 left and 3 down. Well, 4 down, sorry. This is no, because this went probably, let's see, a cubic function, where did it start? It started at 0. So here's my point. It went 2 left. No, this graph's going by 2s. So this went 4 left and 2 up. So that's not it. This one went 1 left and 4 down. That's actually my graph right there. But you can see what I'm doing. I'm recognizing that this point here originally started at the origin. So I know what my parent function looks like, and I'm looking at that transformation. This one would be 1 right, 4 down. 1 right, 2 up. In B, or 2, absolute value, so it has to be a V. 2 right, 1 up. 2 right, 1 up. So it's C. Okay, and then I'm going to look at this and I'm going to say, all right, now tell me what was the transformation that occurred here? Well, this was an absolute value function, so it's always good to have that. It was a reflection, so it was flipped. And it was transformed to up. And that's what I want you to write. I just want you to write what happened to the parent function. In 2, this one's a little harder to see because exponential really started here at 1, 1. So it looks to me like this went up 1 over 1. There's my transformation. So it went right 1, up 1. And here's a cubic. So cubic would have started here at origin and gone 3 left, 1 down. 3 left, whoops, lefts, 1 down. And that's really all we're after. On the rest of these, we're going to hold off actually a little bit because this slide you don't actually need for this section, nor do you need this one. There you go. So what we're after is simply identifying the transformation, identifying the parent function graph, and then being able to take a look at left, right, up, down, flip, and just identifying that sort of thing. So we're going to hold off and we're going to stop there. Oops. And we'll come back in a little bit and talk about the rest of this and what we have to do in order to find these parts here, what's going on here, because this is different. All right, so take a pause, and when we come back, we'll finish the rest of this packet. All right.